upscaling.
Hello.
Hello.
Yeah. Good morning. Good afternoon. Okay. We are going to give some time because people are just joining, okay? Don't know what is happening. People are not joining. We're going to give another 5 minutes because people are telling me that they are running late. No, they are not done. I don't know if there has been any issue on, as you said, that it was going to be an exercise. People have got scared. I don't know what is happening. Mhm. This is strange. I'm trying to ask. One more. Okay, so maybe you can start. People will, I hope, they will keep joining. So, because the timing was clear, it was 11:30. I'm just checking, but 11:30, sorry, 12:30 in Europe, 5 o'clock. This weekend has been a change of timing in Europe, no? And that has come yesterday. Also, there were some people who joined later because they got confused with the timing. But even though in the program is correctly done, but I don't know if something else has happened, but we at least we have some people with us. So let's start and let's see what we can, how you want to go through this, how have you planned this practical exercise, Bakshish, Gerson? How are you going to the final break
Yes.
exercise? Yeah,
Yeah. So today we'll be covering a few concepts in the domain of machine learning. So
very good.
basically the basic, yeah. So the basic notions of machine learning. We'll be going through a set of basic concepts with examples of different techniques that are used. And after that, we'll also be doing a small set of activity after the slides after we are done with the slides. So I think maybe we can wait for one more minute if others are joining, and then we can start. I think you're on mute.
Just checking with the lecturers, the professors, and they say yes, they should be
Okay.
joining, they should be joining, but it's not happening. So yeah, we'll wait for another 2 minutes, and then we'll wait for two
Okay.
minutes. Okay.
Okay.
Okay, let's start, Bakshish.
Let's start. So today we'll be covering few basic notions in the domain of machine learning. And here I share my screen with everybody. I hope it is visible.
Yes.
Great. Glad to know. So yes, so the title for today's session is Methods of Data Science, Basic Notions of Machine Learning. So as we have discussed over the past few days in various sessions, that machine learning requires data, and the data that is being fed to the machine, we add a certain amount of features which are there. So when we say features, so let's say that when we're looking at data, now one common term that often while working on maths or data is that, so what is data? Let's say X. So in when we are feeding the data X into a machine learning model, so what are those features that how we look at it? For example, the feature that can describe a data. So like as you can see in the slide, example of a volume of storage, height of a person, income of a person. Similarly, we also have different terms, different units. So as we discussed in yesterday's analysis, that which was on the number of deaths which was caused due to road accidents. So how different countries over the different years had different amount of deaths that had happened. So we had we had terms like the year in which the death has happened, the country in which the death has happened, and also the number, the numeric value of the death. So when like this was that was just an example. So there could be any different any particular type of data that is being fed into a system. Now that system where the data is fed, we are also expecting an output of it in the machine when the data is being trained. So the output in while we are training the data, we would work on to understand basis the goal that we have. So for example, in the slide as you can see, so if we have to estimate a property. So let's say like you can see that this cost of storage, weight of a person, this is based on just examples that are there. And the model is based on a function where we work on the input variables and expected outcome, at expected output that we would like to have from the machine. So these terms might sound a little vague right now, but as we go further, these concepts would get more clear. So as you can see, so what is the training data? So when we are feeding data to a ML system, a machine learning system, we generally use 80 to 90% of the data for training. As you can see in the figure, so we input the data and there's an output. And like as you can see that there could be a slope and an intercept of the model, but it would depend on the kind of methodology that we are following. There are different methods that are there in the machine learning system. We'll be discussing a few of them. just to give an understanding of how these systems function. And to make the system function, we test the data on the model that we are working on. And this testing, basically, generally we use 10 to 20% of the data for testing. And further on that, we make modifications or any kind of mid course corrections that are required to basically optimize for improved results in the ML model that we are for the ML model that we are creating. As I also had given examples in the first session. So, for example, how uh, in a computer vision system, how different images or videos are given to train the machine and understand the machine different faces or different animals or anything. We'll be also briefly discussing the classic example of a flower, which will come forward. Again, a few technical terms. I am not going into the details of these technical terms, but it's important to know these terms, such as you can see, the term called precision. Basically, precision is a measure of a probability that an event that is classified with a model, if it has been classified correctly or not. That is how basically we would need to. So there's a formula also for it, that, as you can see. So precision is a true positive divided by a true positive plus false positive, which is basically calculated through the confusion matrix, as you can see on the right side. Similarly, we have another important term called recall. So recall value is basically it's calculated as a fraction of the correctly classified ones among all the real ones. So it's important to understand it through, I mean, once if you are like, these are terms important to know, and in the future when you explore the field further, you would hear these terms further more, and then this will help you understand your strengthen your basic concepts in this domain of machine learning and data science. Then third term, again, this is a term that you might have heard a lot, which is called accuracy. So accuracy is basically a fraction of the successful predictions with respect to the total number of records that we have with regards to the data that we are dealing with. And the accuracy is calculated as the true positive plus true added by the true negative divided by the true positive plus false positive plus true negative and false negative. That helps us calculate the accuracy. These are just the formulas, but more than the formula, I'd say it's important to understand the concept and the importance of these concepts, because once you are training a model, these values will help understand the optimization or the efficiency of the models that are being created. Moving on. So these are two common types of analysis that is done. Regression analysis, that I believe some of you would have already heard of in your mathematics or in your statistics class. uh, and also association. So association in simple terms is basically what are the relationships that is being shared by the data that we are dealing with. Let's say the let's say we have a data of rainfall and air pollution. And as we know, whenever there's a rainfall happening in a city, the pollution of that city automatically gets reduced a lot. Why? Because basically the rain reduces, like, brings down all the polluted air particles down to the surface, which reduces the pollution in the air. Similarly, there are multiple examples that are there with regards to this, how these different variables can impact each other and how they have their own relationship with each other. Moving on, we have clustering. So clustering, basically, it's to identify different clusters within the data set that we are dealing with. So we will have a few examples of clustering moving forward. Similarly, for classification, so basically it is to help us understand that if a particular data point that is that belongs to a predefined class, and the model that is being made, the prediction of the model is such that it is classifying the particular data point to the intended output of classification that it should have. So will so one common example could be of classifying different images in different sets. Let's say images of animals or particular objects, how those can be classified or should be classified in the model that we are creating. Moving on to time series. So we worked on a time series data just yesterday when we were looking at the different deaths caused due to accidents. So in that, the time series data can help us predict. So one common prediction, let's say, that all of you would have seen, that is a trend that we saw, that the number of deaths was reducing from the year 2000 to 2021. So that if we could make prediction of the number of deaths, so in terms of the percentage values or in terms of the absolute value of the reduction in the number of deaths that were happening through the data set that we were analyzing for different countries. And it was also visible that few countries had higher number of deaths happening. For example, as we saw Germany, as we saw France, as we saw Italy, while others were a little lower as compared to others. There could be multiple reasons behind that, and also one common one basic foundational reason could be also the number of population. These countries would have a higher may have a higher population as compared to others, or might even have better policies with regards to road and traffic. So these could be one of the reasons. Moving on. So as I was talking about regression and classification. So basically, regression could be, let's say, what will be the temperature tomorrow, while classification would be that if it be hot or cold. So like basically classifying it, in the way that a particular system would. So this was required to feed in the system that, let's say, any temperature below, let's say, 60 Fahrenheit is cold, while any temperature above 60 Fahrenheit would be hot. Similarly, for in a country like India, if we like, let's say any temperature above 24 degrees Celsius, let's say, to be hot, while any temperature below 24 degrees Celsius to be cold. So basically, the algorithm, the machine needs to be informed and trained in such a way that the data that is being fed, it can tell us percentage values or absolute values of basically the data points, that if, let's say, 20% or 20% is cold and 80% is hot, depending, let's say, that we can classify our country's temperature, that out of the 365 days, only 300 days are hot and rest of the 65 days are cold. That's how we can also like just imagine and visualize how these tools can be used. Moving forward. Yes, so this is another simple example of unsupervised and supervised learning, which is classification and clustering. So for unsupervised learning, like as you can see the classification, we are inputting raw data of different fruits, as you can see, apple, banana, and mango. And we have an interpretation, like basically a training a data set with an algorithm towards it, and the data being processed, the output being different fruits that are there, as we can see in the cluster. While on the right side, in classification, we have multiple uh, we also have mango, we have apple, and we have another fruit. And in the algorithm, it basically the output processes these three with different classifiers. So we can see apple classified separately. uh, I'm forgetting the name of this fruit. So the one in the green being classified separately, and then we have pear, or the one in the yellow color at the bottom. So these three are classified differently, and this is through the classification supervised learning model, while the other one is an unsupervised model. So the idea is that in a supervised learning model, we are having an intended goal with the machine, the data that we are training with, based on the algorithm that we are providing. While unsupervised data is more exploratory in nature, and clustering is done to understand how the data takes us with the output. Moving on. So as I was mentioning, we have so this is a classic example of the iris flower dataset, one of the very initial data sets on a multivariate data set, which was done by Ronald Fisher for a data set of 50 samples with three species of the iris flower. As you can see, the three iris flower images of those three: Iris setosa, Iris virginica, and Iris versicolor. So this was done through four different features. As you can see, length, those four features are length and width, which is in centimeter, and sepals and petals. These are the four features that were taken for understanding the different categories of flower that a particular image, like the image, would tell the system, help the system understand to classify it. So we'll see a few figures with regards to this. So as you can see, these dots or these charts that you can see on the right, they tell us in terms of understanding the color of the particular. So you can see the legend on the right. The blue one stands for Iris setosa, the orange one stands for Iris versicolor, and the green one stands for Iris virginica. So this data helps a data scientist to classify it. And this was, as Gerson had also already mentioned, about the Seaborn, and we had briefly touched upon it in the visualizations yesterday. So it's a Seaborn pair plot of the Iris dataset, which shows different formations, and the non-diagonal part is basically, it's a scatter plot which shows those different clusters. We'll see some more. We'll see one more figure of it. Yes, yeah. So yes, so that was to basically understand about the, from a example of a flower, so how these three can be classified. And as now going forward, we would see different parameters of data quality. So as we discussed in one of the formulas and one of the concepts earlier, accuracy. So when we say accuracy, it's basically being accurate to the real world scenarios and reflecting the real world objects. Second, the completeness of the data. So when we say completeness, it basically means the basically the measure of the data's ability to be delivering on all the mandatory values that are available successfully. Third being the consistency of data. Basically, when we say consistency of data, we mean that data should be uniform, and it can be, I mean, if it's even better if it comes from multiple sources. So as we saw in yesterday's data while we were working on, we did not have three data values for the accident deaths for UK. So in a way, data was inconsistent because we did not have data for 3 years for UK for the accident-related deaths that were caused. So I mean, when we are working on data sets, it's important that we try to ensure that data is consistent and uniform with regards to that. Fourth, timeliness of data. So basically, the data that is being made available, it's available all throughout whenever it's needed. It's not something that because over years that we might need more data for analysis as years pass or as months pass, depending on the unit of calculation. In yesterday's analysis, our unit of calculation was through years and countries with regards to the deaths. So similarly, the availability of data and timeliness is important. Fifth, the uniqueness. So when we say uniqueness, it basically means that we try to avoid duplications or information that is overlapping across data sets, and because that would then mm, create errors in the data, or the data, the final output or analysis might not be as accurate as we would expect it to be. That's where the uniqueness of data comes in place. And last but not the least, the validity of the data, which is basically having following a particular set of rules or parameters. So this could be rules or parameters followed by the government, followed by a non-profit or a for-profit organization, basically following the required data related protocols that should be followed while the data quality, to ensure that data quality is maintained. Moving on, so yeah, this was the figure that I was referring to earlier, that how this each and every data point basically refers to the length, or basically you can see on the top we have 2 centimeter, 3 centimeter, 4 centimeter. Those basically, those data values refer to the length of the petals, sepal length and petal length. That helps the machine learning system to classify, and this information is I mean, it's fed to the machine so that the machine can understand how to classify the different kinds of flowers in the three categories that was discussed earlier: Iris setosa, Iris versicolor, and Iris virginica, depending on the sepal length, width, and petal length and width, based on these criterias. And moving on, So these are some domain agnostic techniques of the concepts that we have discussed till now. So yes, so as I had discussed earlier about correlation, so correlation, it's basically a relationship between a few variables. The relationship could be positive, negative, linear, or non-linear. Like I had given the example earlier of rainfall and air pollution. So as rainfall can decrease air pollution, similarly, let's say that if there's a prolonged period of no rain in a region, or which is supplemented by industrial activity in the region, or vehicular pollution, or any other pollution causing reason, that can lead to a deterioration of air quality in the region. Similarly, any two factors that can that can impact. And as you can see in the example, so air pollution can also lead to increase in hospital admissions with regards to any air pollution related problem. It could be heart related diseases, it could be cardiovascular diseases, or anything which has to do with air pollution. Moving on, logistic regression. So it's a supervised machine learning technique, and in this technique, classification is done through binary classifications. And so, for example, like as written, that if there's a no show in an airline, so a show or a no show, so that's how data can be classified. That, let's say, 97.5% of passengers had reported being present there at the venue of at the airport. Moving on, optimized algorithms. So these are algorithms that are made with the best possible optimal solution from a set of possible solutions that are under certain constraints as given. And the idea in this kind of algorithm is to optimize the data set that we are working with. Moving on, we have clustering and classification that has already been briefly discussed. So you can see a few more examples. Some of these examples you'll see with a different, like a climate perspective, to help understand how these concepts can be used. Since this has been discussed, I'll just quickly move forward. Yes, predictive modeling and analysis. So this is one of the very predictive systems. It's one of the key, one of the, like, very heavily used machine learning method, where these are the different examples how forecasting is done with regards to any particular requirement depending on the need. So as you can see, this example of hurricane prediction, we'll be discussing briefly the Google flu trends. This was something that was done through basically a prediction that was made through the Google searches that were made on the Google search engine, where it gave an insight to through Google, like how a particular public health disease was on the brink of it based on the number of people who were searching for it. So predictive modeling is a very uh, important domain in the domain of machine learning. Moving on. So we have association rule. It's similar
Está
to
llegando todos los
correlation.
impuestos.
I think there's some disturbance in the background.
Yeah. Isidora,
Okay.
please, can you mute yourself?
No, okay, moving on. So this is based on, so you can see the first example, beer and diaper. So it was based on a study that was found that found that the correlation between purchase of beer and diaper in the US, and like the resources for it will be shared. But similar to other products, like when we go to a supermart, certain kind of products are kept at the billing counter, so that people are more inclined towards purchasing them, while there are others, like basically the arrangement of products at a supermart can also have their own correlation. And similarly, like as you can see that pregnancy prediction, so there are a lot of other products that are correlated with pregnancy that that a consumer might buy. Similarly, this association rule can be used for different kind of products and different kind of relationships of products, or like any kind of domain, not just in products, but for anything that could be possible, which has anything which can have a correlation. That could also be for let's say for vehicles, so batteries, like electric vehicle, electric batteries, similarly for uh, combustion based engines, because they have their own correlation. While we can also see it with different drinking products. So let's say for coffee and tea, how there's association visible with them as well. Moving on, we have deep learning and neural network. These are a few advanced concepts, I'll say. So I mean, I'd say that it's important to know these concepts initially to begin with, and as you explore your future with data science, you can go into the depths of it. But just to give you a sort of a overview, so a neural network is a computational model which is very much like the idea is to align it with how a human brain works. Just like how a human brain has neurons, a neural network is expected to work in a manner which is similar to how a human learns, processes a data that is being given to a human, learns the pattern and makes predictions. So the larger idea of neural network is that. And this large concept, so as we have heard of as we have heard of machine learning, there's another concept called deep learning, which is primarily driven through neural networks, through different kind of models that are there. And it also uses feature engineering. But I mean, we're not going into depths of it. We're just like telling you the concept for your understanding, for your future goals with reference to data science, so that you can explore these domains as well. Moving on, we have these two techniques as well. So we have remote sensing and GIS mapping, which can be so like yesterday when we were working on the data set analysis, one of the last visualization was also having the different countries and a GIS based map that was created through the Python visualization that was used. And similarly, we can do a lot of different kind of visualizations as well with the use of GIS based systems. And it's particularly also useful for any kind of analysis which in particular domains, such as city planning, such as agriculture, such as forest fires, predicting forest fires, and even for rainfall, or any domain where we have geographical systems involved, even for transport related planning as well. So that's where these systems can help us plan things better. And yes, moving on, time series analysis. So as we discussed yesterday in the data set that we worked with, so time series, that was a time series data that we had discussed, which was, as you know, from 2020 to 21, the accident-related deaths that had happened. Yes, a last few set of techniques. So we have natural language processing that I think I briefly touched upon in the first session as well. So basically, this is a particular technique that is used to analyze text or speech data. So this could be in form of text, it could be in form of audio speech. So basically, the goal of it is to basically draw insights from the data that we have, or text or speech. This could be through, so these are some of the examples. So as you can see, sentiment analysis, text summarization, or chatbot communication. Even basically, these systems are also designed to uh, interpret and look at data from a human perspective, how a human might look at it. So it could also include aspects of understanding the tonality of the voice that we are working with. So let's say if a sentence is spoken by, or we have an audio file, how different tones depend, I mean, basically help us understand if the particular sentence is said in anger, in love, or out of fear, or out of any emotion that's there out there. So NLP is a very emerging domain. A lot of the voice based systems that work in, like even in our phone, when we say that say to our phone, call, you can take any name of your friend, or you can just say to your phone to put an alarm. So all those systems are made out of natural language processing of that is being followed by our phones. And our phone operating systems are trained such that they're able to understand the language that we speak to them. Yes. Moving on, computer vision. So computer vision is a lot about using images or videos to basically analyze it. So as I had discussed earlier as well, We have driverless cars these days, and other different kinds of systems where images and videos are analyzed by a machine learning model, which then further helps the ML model to take decisions based on the past data that it has been trained on. Yes. Moving on. Large language models, we all have heard of models such as ChatGPT or even Gemini, and different kind of models where basically a system is trained based on the language systems that are being fed into it and the data that has been it has been trained on. And basically these are very they are generally trained on neural networks, which is very much in sync with how a human would want to think about. So for example, a chat GPT or any kind of a GPT system, if we are asking the GPT to work on humanizing the text would be then toned down and from a different perspective. So similarly, any kind of command that's given, that's how a system is expected to act on it, because it has been trained like that. Similarly, generative AI. So generative AI is basically a system that's being taught on patterns, that's being trained through the existing data. And the idea of it is very different. So it has images, text, music, or even software code for a system to learn on. And generative AI is another emerging domain, an emerging field in this domain. Moving on, market basket analysis. These are like one of the examples that we had discussed earlier as well. Then we have customer segmentation, basically, which is to understand how customers function in a particular market with distinct groups based on their own characteristics. So these could be customers that are particularly inclined to purchase certain products, or who have a higher or a lower purchasing capacity, depending on. So this is basically very much relevant to corporate organizations and how they can devise their marketing strategies to provide personalized experiences. One example that I can give of customer segmentation is that a lot of times we see ads on Google or any platform that we are going, and we are uh, pushed a particular type of ad, some a particular type of advertisement that we have, something that we have searched earlier. So a lot of times this happens through Amazon, through other multinational uh, product centric e-commerce portals, where we are given ads of that, because our us as a user is being segmented to a particular category of which we get those ads. That's where the data that is being gathered. So a lot of times we see cookies or like other search history data that is being used by different channels, where this data is used to give us ads. Then we have supply chain optimization. So this is again work towards, the idea is to optimize and enhance the supply chain in the best manner possible. Moving on to revenue management systems. So these are basically RMS tools, which is to use forecasting techniques, set optimal pricing or managing inventory, understanding the demand and supply in the market based on the past data, or even based on the trend, the near trend of the purchasing trends that are visible with the particular economies or a particular e-commerce website. Then yes, yeah, one of the last slides, Google flu trends. So as I was mentioning earlier, so the problem that was seen in 2008, that was identified. So Google had launched the Google Flu Trends initiative, which had an aim to predict flu outbreaks by analyzing through the search query data systems. So the goal for this system was to filter out terms that are related to flu, such as cough, fever, or flu symptoms. So let's say that when people were using these terms on the internet, on the Google search engine, so Google noticed this, and through these systems, Google was able to identify which are the zones or which are the areas where more people are searching for these search terms, such as cough, fever, or flu. And based on that, it was able to draw a correlation between actual flu cases and flu related search items. So this was a predictive model which was based on historical data, and the outcome of it was basically identifying public health, like basically a breakthrough in the public health surveilling systems where big data could be used for tracking disease. And this had basically, I mean, it had overestimated the number of flu cases. It also tells us one of the reasons why these systems needs to be designed. And this is again almost 15 years ago, 2008, where overfitting was seen of the model, where basically the algorithm of Google became overly sensitive to the spike in searches. And this was further triggered by the media reports about the flu rather than the actual disease that was seen. So while this system was being implemented, it had used predictive modeling, time series, and correlation analysis as part of it. It was further discontinued in 2015 due to its failure with the with the wrongly predicting the flu trends. But this, as an example, really helps us understand how these systems work and what are the different tools and techniques that can help us or help machine learning models be more effective, and be sure that we are not overfitting or underfitting the model. So basically, overfitting and underfitting would mean that the results are not giving a higher estimate than the true value, or a lower estimate, underfitting being a lower estimate than the true number of cases. So this is one example of a ML based model that was ran in 2008. And I think, yeah, that was the last slide. So in case anybody has any other queries, please feel free to reach out to me, and I'll be happy to help. So now, but I mean, before I hand it over to Gerson, if anybody has any queries, anybody would like to ask anything with regards to this, we can stop for a minute, or otherwise I can just hand it over to Gerson for the next set of slides,
Yeah,
next set of
thank you,
this.
Ashish. I have some question. I was just listening to you, and I have an impression. I don't know. I'm not a student, a college student. Maybe for them, this is clear. But for me, when I listen to you and I see all these um, techniques, no, all these things that is, it's like going to a library and to have shelves full of books, no, but you don't know where to start reading, no. You need a guidance. You need someone who needs to tell you, okay, I guess that you have shown us also different sectors, different uses, no, but um, how to reach, no, how to select which is the right book at the right time I need to read, or I need to, no, is there any guidance on this word? Because it looks like someone has provided all these techniques available to all, no, and most of them in open source. You can go and, but who guides us in this new world when you have all these tools at hand, and someone has to guide you and has to guide you how to go through it, no? If I were a student, how would you advise me to tackle this new era?
Right. Thank you. Thank you for that question. I really appreciate it. It's a great question, and it would come to anybody's mind to understand. So to be as a beginner, so I can suggest a few books. I'll share it in the chat as well. Meanwhile, I'll just name those books. So those books are for anybody's conceptual understanding. So one of the book that I would like to recommend is, I'm just writing it in the chat. The book title in itself. Okay, I'm not able to send a message in the chat. Okay. Yeah, so I'll tell the name of the book, and maybe at a later stage, if I'm able to send a message on the chat, I will. So the name of the book is called Machine Learning for Absolute Beginners by Oliver Theobald, which is basically, it's a book which is designed for people who have zero prior knowledge of coding, math, or statistics, which anybody can pick up from. Then in addition to that, what a lot of people, at least in my, like what I see from in my friend circle or people who I have learned from, is through online programs which are available on YouTube. There are a lot of YouTube playlists which anybody who's interested in the concept of machine learning or data science can pick up from. Then in addition to YouTube, because YouTube is a form of audio visual content learning, but it's important to also perform through different projects that we can pick up from. So I would suggest the students here to register themselves, create an account in on the platform called GitHub. So GitHub is a platform community where a lot of people who work in the tech domain, especially data science, they upload their projects that they have done, and it's designed, those projects are designed and being shared in such a way that people can start from, they can start learning through them. So I'll also, what I would do, and we'll share a file which has a link of these resources from GitHub, from YouTube, from other online resources such as like earlier had discussed about Coursera, EDX, different kind of playlists that are there. As Gerson had discussed about Trinket. Trinket is one of the platforms which anybody who is starting to learn about data science so can start from there. These are places where people can go and practice, while there are a few books that, like one of the book that I mentioned, people can learn those and get an understanding from there. I'll name one more book. So the earlier book that I had mentioned had no is for people who are not particularly inclined towards maths, and anybody has somebody who has no background in maths or statistics. Another book I'd suggest is a little driven, because a lot of data science is statistics heavy, not maths specifically. I mean, statistics is a part of maths, but so this book is called An Introduction to Statistical Learning by Gareth James. So this is a little stats focused, but because statistics is an important concept in machine learning or data science, it would really help them. So it would cover tree-based models, resample methods, or like many other different concepts in the domain of machine learning, and a few other books that I can share. And once the chat is enabled, I would share the links with everybody so that people can gain through that and basically advance their career in this domain of data science and machine learning, and help everybody towards a more inclusive and enabled technology-based systems. That's what I'll say. I hope I was able to answer your question.
Thank you. Yeah, I think it's great.
Yes, thank you. I would like to hand over to Gerson for the last part of the session.
Hey everyone. So let's just touch on some other things based on the conversation to keep the conversation going, right? So, like for me, when I started my career, the main problem was I had studied a lot of books and theory and practiced projects and things like that, but it was only when I actually started working on real projects that I really everything started coming together and I really started growing. Right. So that is the challenge. It's finding something that you can, that a real world problem that you're working on that you need to automate. Right. So I'll give you an example. Right. So when I when we go to the doctor and all that, we used to get, every time we did a blood test and the regular blood tests or whatever, we would get the the doctors, and this was in Canada. They would give us all of the everything in terms of like your whole history. Every time you did a blood test, they would show you all your all your levels, blood levels, and things like that. And so you could actually download an Excel file with your entire history. So one of the things I did is like, okay, this is a good good way for me to use Pandas and all of these data visualizations and all of that, so I could see trends. And this is for my health, but you could apply to someone else's health. So so this is an example, right? An example of an everyday thing I encountered. I had the opportunity. Uh, I had a file with lots of data about my health, and I said, oh, this is a good opportunity for me to visualize it and things like that. So even though I had at that point of time, I was aware of pandas and all of these visualization tools, but I'd never really had a real use case for it, right? So I'd never really used it, and this was a perfect example for me to use it, right? So this is something that it's when you actually have a real example, that's when you'll actually make good use of it. Anyway, so we got over 30 minutes, and I thought like let's kind of do a little more hands-on, because I like my style is more hands-on. I don't I don't I don't use slides. um, and I'll show you something a little different. So Bakshish has touched upon this a little bit, which is a concept called sentiment analysis. Okay, so very interesting concept, and I will show you how easy it is to do that. So I've got a new, I'll just call it sentiment analysis. Okay, so I've got two files over here, reviews and review small. Okay, so if I just look at the small one, you can see that it just has a list of comments, right? Simple ones like, I love this product, it's amazing, this is the worst experience I've had, pretty good, I enjoyed it, I didn't like the color at all, and so on, right? So we've got a bunch of these. And then I've got reviews, which is a lot bigger. It won't even load because it's too big, right? It's really, really huge. I got it from Kaggle, and there are 400,000 of these comments, reviews, right? Lots and lots of them. So it would be nice to see, to see which of these are positive reviews and which of these are negative reviews. You're like, can Python really do that? Can it actually tell which ones are positive and which ones are negative? Well, yes, they can. Right? So this is in the field of machine learning or artificial intelligence called natural language processing. ChatGPT is part of it, and actually it's a lot easier to believe now that people have worked with ChatGPT. But a few years ago, it was really hard to believe that something like this was actually possible. So I'll just show you quickly how we can rank each comment and see how positive or how negative it is, right? So in order to do that, we need a library called TextBlob. Remember I said that you have to pull in a library from the outside. So this is called TextBlob, right? TextBlob. Okay, so TextBlob is the name of the library. And if I run that, so it's, for me, this is already loaded, but if it's not loaded for you, then you have to install, you have to pull it. So TextBlob is not by the people who made Python, right? It's by someone else. Anyone can create these modules. So if I just do a quick search for TextBlob, you'll see that it's created by someone else. This is not created by the makers of Python, right? It's created by someone else. So you have to install it on a system. And the way you do that is pip, so exclamation mark, then pip is a package manager for Python, pip install, and then TextBlob. And generally they'll tell you here somewhere, I'll put here, right? Install. And if you're on Jupyter notebooks, you have to put an exclamation before that. And I already have it installed. So I'll just say requirement already satisfied. But if you don't have it installed, then you'll see it. It will install the whole thing, right? Okay, so now that you've installed that, the next thing is we need to load the file, right? So the file that we are dealing with is called, I'm going to read the small one first, and then I'll go with the big one. So reviews underscore small dot txt. Okay, and then what I'm going to do is I'm going to read that one by one, read these lines one by one, and I'm going to save it into a list called comments. Okay, so this is an array now. Remember, previously we had seen square brackets, and you can put a list of things in that. So right now we just have an empty list. There's nothing in there, no comments. We have to read the files one by one, right? So we haven't really seen this, but let's learn. We've seen a lot of these, if and while and all of that. So there's another one of these called with. Okay, so with open. So we're opening the file. Okay, and one of the things we have to do is we have to tell it whether you're reading the file or writing the file. So this time I'm reading the file. I'm going to read the file. So you say comma and then you say R for read. If you were writing to the file, you would put W, right? So we're reading the file, and then you've got to give it a variable, right? So let's say I'll call this file name, and then as file. Okay. Okay, and then what we can do is we can say for line in enumerate file. And what we're doing here is we are taking the file and we are converting it into a list, right? So we have one line, many lines over here, and we're going one line at a time. Okay, and then for each line, we're going to go comments dot append, right? We're going to take that line, whatever that line is, and we're going to append it. We're going to add it to that comments list. Okay, so we're taking actually just a line. Okay, so we have that, and if I run that now, okay, I can now see comments. Okay, and so now it has, these are all of the comments, right? So lots of comments over here. Okay, so it looks like it's giving me the line number and the comment. Okay, and I only want, so this is line 0, line 1, line 2, line 3, and so on, right? So I only want the comments, and so I won't explain, but if I do that, now I only get the comments. Okay, so one line per comments. I have a list of comments, and that's exactly what I want. You can also see that there's a \n over there. I'll just ignore it. But that's basically a new line, right? You might want to do some data cleanup and all of that. But anyway, so we've got some comments here to work on. And then what I want to do is I want to group these into groups, right? So there are some that are positive, right? So let's say amazing, truly a 5-star product. That's a positive one. Not up to the mark, feels cheaply made. That's a negative one, right? So we've got some positive reviews and some negative. Not worth the price at all. That's a negative review. This is the worst quality I've seen in a long time. Negative review. And then maybe some of them are natural. Neutral, right? So you might have like some neutral one. It's all right. Does what it's supposed to do. That's neutral, right? It's not positive. It's not negative. So let's try and group this now into some buckets. Okay. So we'll have like a positive group. And I'm going to make all of these lists, right? So I've got a positive list, I've got a negative list, and I've got a neutral list, right? So if it's neutral, it goes into the neutral list. If it's negative, it goes to the negative list, and if it's positive, it goes into the positive list. Okay. So now is the fun part, right? Now we're going to actually check. We are going to use this text blob, and we're going to categorize it as positive or negative. Okay. So how do we do that? We loop through the comments. So for comment in comments, we did this. Oops, that's an error. Okay, so the way we do that is we call the text blob. This is called a class. Okay, so this thing here is a class, text blob, and we have to give it something, right? It's something like a function. So we're giving it the comment, right? We give it the comment, and then it throws back the results of the analysis. So we catch that and we store it in a variable called analysis. Okay, and then And then we can actually look at the analysis. So let's just print it out and see what we have. Okay, it's going to print a lot of them. Okay, just seems to be printing just the comment itself, right? Not really helpful. But this is actually not just a string, right? This is actually a more complicated thing. So it has all of these things within it, right? So it's analyzed the comment and it's processed some things. And one of the things it has is the sentiment. Okay, so let's run that now and see. Okay, so now you can see that it's given me now the sentiment for each of these things, right? So it's got a polarity and a subjectivity. Okay, so let's look at the polarity, right? Polarity is, you can see some of them are positive, so this is 0.6, and some of them are negative, so 0.1, right? So negative is negative, positive is positive. So if it's a negative comment, then it is -1. So let's look at the very second one. This is the worst experience I've ever had. Okay, that is a very negative comment. Okay, I love this product, it's amazing. Okay, so that's kind of positive. And so it kind of determines, you know, how positive or how negative it is. Okay, so maybe we just want the polarity. Okay, so if I look at the polarity and I print that out, now I have a list of numbers. Okay, so I have a list of numbers here, and I can do a check now and see if it's within a certain group, right? So if it's, for example, I can say if I don't need to print it, right? I can say if, oops, polarity. I want to save the polarity into a variable. And then I want to say if the polarity, so we did this yesterday, right? If the polarity is less than 0, colon, then I want to append it to the positive, or sorry, negative, right? If it's less than 0 means negative. Append and comment. Okay. Then same way, elif polarity is greater than 0, then add it to the positive. Okay, and then else, so if it's not positive and not negative, means it's 0, it's right in the middle, then I put it in the neutral. Okay, so I run all of this and it takes a while. Okay, not too long, but it takes a while. And now I can actually see these buckets, right? So if I see, if I look at positive, right, I can see only the positive. So these are all positive comments, right? Look at that. All positive. Awesome. This made my day. Could take it or leave it. Blah, blah, blah. Happy with it. Gets the job done. All of that, right? Let's look at the negative ones now. Okay, so we've got these are all the negative ones. The worst quality I've seen. Customer support was unhelpful and rude. Not worth the price. Look at that, right? So this is called natural language processing. It's actually processing language, and it's able to tell if a language is positive or negative, right? And let's look at neutral. Maybe let's see what I need. Okay, so it got some of them, right? I didn't like the color at all. I would have said that is negative, but it's all right, does what it's supposed to do, delivered on time, works like a charm, feels cheap and poorly constructed. So these are what it's considering neutral, right? And if you want, you could actually have more categories. Maybe you have like very positive, very negative, all of that, right? So this is what that looks like. And now what we can do is we can visualize this, right? So we can say let's create some buckets, okay? And so we have 3 buckets here. We have the positive bucket, we have the negative bucket, and then we have the, actually let's put the neutral one in the middle. Okay, so we have positive, neutral, and negative. Okay, in fact, actually let's switch this. Let's make it negative, neutral, and then positive. Okay, so we've got that, and then we've got the counts. So we need the counts. So remember, we use length. We want to, if we want the length of something, we use length. So we want the length of the negative. They have to match, right? These two have to match. We want the length of the neutral, and we want the length of the positive, right? So we have that. Now we have all the counts. Okay. And then what we'll do is we'll put this into a pandas. We've done pandas yesterday, right? So import pandas as PD. Okay. And then we can create a data frame, pd.data frame. We didn't do this yesterday, but it's a similar concept, right? We're using the data frame constructor here. And we want the sentiment, which is the buckets group, and then we want the count, and we put the counts in that, right? So we've got that, and then let's display the data frame. So now we're loading it, we're creating a data frame, and we have sentiment, which is negative, neutral, and positive, and then we have the count. So we have 22 negative comments, 7 neutral comments, and 37 positive comments. Okay, so now it's time to create some plots. Okay, you can see that it uses AI now, and it tries and suggests, maybe it has recommended plots based on this information. Okay, so if I click on that, let's see what happens. It generates some plots, right? So it saves you time. So this is how, a little bit of AI here and there. And maybe I like this one. So I'm going to click on that one. And then basically it's created the code for me. It doesn't look actually correct. What is going on here? So it's using matplotlib and CDOM. I don't know what it's doing, but this is definitely not correct. Yeah. Okay. I'm going to make my own plot. Okay. So remember we had plotly.express as px, right? So that was the library that does all of the plots. And then we want a bar. Let's do a bar graph. And I'm going to take the data frame, which is there, right? And on the x-axis, I want the sentiment. And on the y-axis, I want the, okay. And then I go fg.fig.show. Okay, so that's the bare minimum required in order to see. Okay, so we've got negative, neutral, positive, right? And now you can go and clean this up. I can change that, labels and all of that. I've done that like yesterday. I don't want to waste time with that. But one thing now is, we've seen with a few columns, but what about if we want the huge, the big one, right? This is 400,000 rows. Okay, so let's do a couple of things. Let me remove that. Okay, neutral, clean that up. Okay, so a couple of things. One is when we're dealing with lots of data, like 400,000 rows, we probably want to start with something smaller, right? So instead of doing 400,000, let's just do like 100. Let's start with 100. So what I'm going to say is, if the index is less than 100, then comments append line. Okay, so all I'm doing is I'm putting like a cap, so it's only going to work for 100 comments. Okay, that's the first thing. Second thing is, even if I do that, and now I'm going to change this to reviews, right? So let's look at that, and let's see how long it takes. It takes 0 seconds, so that's still good, right? And let's see the next steps. Okay, so that takes also 0 seconds, right? Let's keep going. So now I'm using the other list, right? 22, 2, and 76. Okay, interesting. Okay, and that is my group now with the other one, which is huge, right? The big list. Okay, so let's go bigger. Let's go 1,000. Okay. Okay, so now you can see. So this is taken 1 second. It's still not very long. Okay. So now we've got about 700 positive comments, very little neutral comments, and then negative the thing. So one of the things you notice is that since neutral is really small, remember we're saying neutral has to be 0, right? So we probably want we probably want like something even like 0.1 maybe should also be neutral, right? So we're going to say is less than minus 0.1, and then this is greater than plus 0.1, right? So what we're doing here is we are making the buckets the neutral bucket a little bigger. So now we have it's a little more balanced, right? Still a lot of positive, but a little more balanced over there. So this kind of looks a little better. All right. So now let's go up to 10,000, right? Okay, now see, so now it's going to take, this part was still really quick. Let's see how long this takes. Okay, so now this is taking a little while now. Okay. Okay, so it took 7 seconds. Okay, so now I'm going to show you another library that you can use for any loop to show you progress if you're dealing with a large data set and big loops and all that. And it's called TQDM. I love that library. It's called so from TQDM, import TQDM. Okay, and what is TQDM? It just shows you the progress, and I'll show you what I mean. So now instead of saying for comment in comments, I'm going to say for comment in TQDM comments. It's a function. Okay, and now when I run that, see what happens. Just by adding this line and then this function here, I get a progress bar. Look at that. Beautiful, right? So it's showing me the progress. I got 100,000. What is that? 10,000. So I got 10,000, and it's actually showing me the progress. So I can, instead of just waiting and waiting and waiting, I can actually tell how long it's going to take, right? And the rest is the same. Okay, so we've got 12,000 on the positive and so on, right? So now let's go 100,000. Okay. And now you can see that this progress bar is really important now because it's going to take a longer time. Look at that. Okay, so you can actually see the progress, see how long it takes. Okay. Meanwhile, you could also have additional, you could have very positive, very negative, whatever, right? Could have a title. Let's add the title while we're waiting. So this is comment, sentiment analysis, something like that. Okay, and so this is the foundation of ChatGPT, right? ChatGPT and all of that, of course, much more complex. ChatGPT can also do sentiment analysis, but of course, it can do lots more things. This program here, TextBlock, is a very simple thing. All it can do is sentiment analysis, right? It doesn't do much else. But okay, so we've got much bigger numbers there. Okay, and so we got 60,000 positive, and then neutral and negative. Okay, so and then if you want to see, let's just see positive. Let's see negative, right? It's going to take a while, but you can see boring, bad influence, blah blah blah, right? So a lot of I won't show you the thing because there's a lot of negativity. I got this on Kaggle, and a lot of vulgar language in that. But anyway, it can detect positive, negative, and neutral, right? So the question is, why would we need something like this? What is the point of something like this, right? And why would you need to do that? So here's the use case. Let's say you have a YouTube channel, or let's say you have an Instagram. You have like a small business, or so whatever you're doing, you're managing the Instagram group or your LinkedIn group or whatever. Right? Depending on the type of platform you have, might be possible to export all the comments, to get all the comments from there, and then you could you could use it in something like this, and you could just get the negative comments. Maybe you want to, you know, maybe you want the negative. The neutral comments are the most useless comments, right? Negative comments is like, okay, how can we improve, right? If you're doing a business, for example, and you want to improve, you can look at the negative comments. Maybe some of them have suggestions, or it's good critique, it's good, feedback, and you can work with that, right? So now you can, if you have thousands and thousands and thousands of negative comments, you can see only the negative ones and then work. Maybe you want, you're feeling down or whatever, and you want to feel positive and you want to feel happy or whatever. So you want to read people's positive comments, right? So then you could go and you can get the positive comments, and you could just read through them, right? So that's another use case. Maybe, and this is more complex, right? So you might have to use something other than text blog. Is you could get it to categorize it as, is it constructive, is it negative and constructive, or is it just negative, right? Because if it's just negative, it's like, oh, it sucks and it's horrible and whatever. Then it's like, okay, it is negative, but there's nothing you can do about it, right? While if it's constructive and negative, then it can actually give you something to work on, right? You can improve your business in this. So that's a very, very, very practical use case of something like sentiment analysis. Anyway, so I just wanted to share another example of use case of AI and machine learning, things like that, and hopefully it helped. Any questions about this or anything else? Okay, so before we wrap up, I'll just close out something. So you can always, yeah, Bakshish.
Yes. Am I audible?
Yes.
Yes.
So I was just wondering, while you were doing it, so one of the neutral cases, it was mentioned that the quality was poorly constructed, something like that, the sentence like that. So because like we are like there are biases, or there are some things that are done. I mean, sometimes you have to work on the data. So in such cases where like let's say that I use a sentence called "the product was not bad." So the term "not bad," it is
Right.
basically like
It has the word
flip
bad
of,
in it, yeah.
yeah, it has the word "bad" in it, but it has the word "not bad." I mean, the two terms. So in such cases, when words are
Yeah.
constructed in such a way that humans would know the meaning of it, but how would when we are working on sentiment analysis or anything similar to this in NLP, then how can we work on the data such that we're able to ensure that the results are accurate?
Yeah, so good question. And so this depends on the quality of the transformer. So with NLP, we are using something. Most of the time, there are other ways of doing it, but these are called transform, right? So in fact, I think the T in GPT is transformers, and the higher the quality of transformers, the better it is at getting these new answers, right? The example I showed you only works for English, right? But there are others that are multilingual, work for multiple languages, right? The thing that you mentioned, not bad. So that I think I'm pretty sure this one would not catch that, because this is a very, you can see that it processed 100,000 comments in within a minute or so. So this is not a very powerful, very smart transformer, and sometimes you have to balance between, like, okay, I need expense is important, or I need high quality, has to be very intelligent, right? So you have to balance between them, and yeah, so it all depends on how big the transformer is and how well the transformer is trained. And that's the thing with not just with NLP, but with all other machine language models. It's only as good as it's trained, right? So if you train it with bad data, poor quality data, if the data set that you're training it with is bad, is poor quality, then the predictions are also going to be low quality, right? If you train it with good quality data, then the predictions will be good quality. So for example, in the case of not bad, if the training data set has a lot of not bad as examples, and you're saying that that is neutral, then it will be able to handle not bad really well, right? So it all depends on how it all depends on the training data that was used to train the model. And it's getting better and better because there is a concept called distillation, where instead of us training models now, we're getting high quality models to train low quality models, right? So we are automating a lot of that process. The very first time it was very difficult because we had to actually come up with thousands and thousands and millions of data set ourselves, right? But now, so even if you look at like some of the not Chat GPT, but some of the other like Llama, Meta, I think Meta's one of their models is Llama. I think it's basically just trained on Chat GPT data, right? So that's called distillation. You're taking the output of a higher model, training a lower model. So they're getting more and more dense. So we're getting smaller models to be smarter and smarter. So this problem is going to improve over time. Like you're going to get better results with these models.
Interesting. Thank you for that clarification. Is that also like, will this kind of an error, it will be considered under a semantic, like a semantic challenge? I mean, semantic difficulty for a
Yeah.
algorithm?
Yeah. So what's happening is with NLP, it's actually converting all of these words and all of that into numbers, right? And words that have similar meaning are closer in number than words that are further away from it. So this is called vectorization. You're vectorizing the text, and that is why if you notice, if you go to Google or ChatGPT also, and you spell something wrongly, right, it's still going to work, right? If you're doing Google search and you use the past tense or present tense or different languages or whatever, it still works. And the reason why is because whether you give it English or Spanish or French or whatever language, it converts it into numbers. And the English word for something is the same as the French word for something. The numbers are going to be very close to each other. So when it's actually processing information, it's processing numbers. It's not doing English. It's not doing any of the languages. It's processing it with numbers. The challenge is to convert the thing that converts it from whatever language into the numbers. That's the challenge, right? That's the embedding. It's called an embedding model. So if you ever see embedding model, that's what the embedding model embeds the language. So you get English embedding models and French and whatever, right? Multilingual, single language, whatever. It tells you, if you're looking at an embedding model, it'll tell you this is specialized in English or this is specialized in these languages or whatever. And semantic basically means that, like you can search for something that sounds like, if you do spelling mistakes, it's still going to find. It's not going to be an exact text match, which is a good thing because
Okay, thank you for that elaborative response.
you're mute.
I think you're on mute.
Yeah, sorry. I just was trying to thank you both because you made a great effort and you actually pass on most of your knowledge. And I know that this is going to be really useful. I was just receiving some messages now saying our class hasn't been cancelled because there are having some how can I say, it's a huge rain unexpected in Spain, and there are many things happening, including many diseases in some areas in Spain, some unexpected. It's like I would like to say tsunami, but it's not. It's like a small tsunami, but maybe we're not ready for that. So, okay. But apart from that, I know that people are willing to go back again to your sessions, and I will share with everyone your personal. You did, but I don't know if I gave Gerson's in case people want to interact with you personally. But okay, you be ready also if you receive personal queries. But I know that many people will go through your sessions, so I'm really grateful for that. They were really good, complete, I would say, because you have gone through different aspects, and I would like to thank you for your collaboration. Tomorrow we'll be completing our 4th day that Yvonne has been attending, I think, two sessions yesterday, today's session also. So I know that he has also been checking whatever you said the days before. So he will conduct our last 2 sessions that are related more to how to extract those data. And I know that also that's going to be very helpful for all. So thank you so much. We are going to wrap up with this if you don't have anything else. So people will be also submitting their feedback, their assessment sheet at the end of the seminar. If something is to be passed on to you, we'll let you know. Okay, so most of the classes have been, particularly in Tajikistan, they have attended with the computer of the teacher, of the professor, but there were more than 46 people in every session. And in the University of the Basque Country, I think they have reached up to 60, 70, depending the session. So you have been addressing around 150 people. So hopefully they will be very helpful for all of them. So thank you so much, and hope to see you again soon.
Bye.